Hello everybody, here's the last lesson for you while I'm away. I'm introducing a new concept in graph, a different sort of asymptote to you, called the oblique asymptote. If you notice, we've always had ones parallel to the x-axis or the y-axis. Now here's one going at an angle, and we can have any angle in fact. Neither horizontal nor vertical, and not a multiple of 360 degrees, of 90 degrees. See, various different ones, and obviously a combination. I mean, if you have a look here, you have that asymptote there, you have these asymptotes here, you have a turning point here. So a variety of graphs around the place. And in fact, they can also be curves, but you won't. It's not in this syllabus. But in fact, when you're doing tertiary maths, you could in fact even have curves. Here's one asymptotic to the graph of what y equals x, or what a graph of y equals sine x, and the y-axis. Here's a graph which is asymptotic to the arm of a parabola and the y-axis, also parabola and the y-axis. Very interesting different shapes. But we'll just be doing the straight line oblique asymptotes. So they occur when a function in x approaches another function in x as x tends to infinity. Now that sounds very confusing, but let's have a look at what that means. Little note, deviation from usual limit calculations. So here, for example, we'd say that the limit of 2x plus 1 as x tends to infinity does not exist, or that the limit equals infinity. Now, when we're dealing with curves, the limit of a polynomial as x tends to infinity remains the polynomial. Polynomial, I hope you'll remember what a polynomial is. And as we are determining how the curves behave along the way. So here's an example. For the limit of the curve, limit of 2x plus 1 as x tends to infinity equals 2x plus 1. And that is the case. As far right as we go, the curve stays 2x plus 1. So perhaps that's part of a function where we now have an oblique asymptote. If we look at this, f of x equals x plus 1 over x. Right, so as x approaches infinity, 1 over x is going to tend to 0. So we have a 0, and we have the x left, and so this function is approaching x. There's nothing wrong with saying this because we still have x tending to infinity. So if you look at the graph of x plus 1 over x, it's asymptotic to x equals 0. Since if you write this as a fraction, a single fraction, it's x squared plus 1 over x. And it's asymptotic to y equals x. So there's the curve. Notice it's asymptotic to x equals 0 because you cannot have x equals 0 in there. But it's also asymptotic to y equals x. And as it says, a clear indication of oblique asymptotes is if you've got to draw the graph where you have a polynomial over a polynomial, like here, that's a polynomial, second degree polynomial over a first degree polynomial, where the numerator is of greater degree than the denominator. So here are second degree over first degree. This is going to give you an oblique asymptote. Let's look at another one, x cubed over x squared plus 1. What I'm going to do with this is I'm going to use long division to find a remainder. This is exactly the same way as if we were reducing something to partial fractions. Do you all remember partial fractions? The first thing we do is look and see if that's equal or higher in degree to this. Then we've got to do a long division first. So let's do this long division. So there's x cubed, what we're dividing into. There's x squared plus 1, what we're dividing by. We say x squared into x cubed gives x. Then you multiply, normal pattern for multiplication, and then you subtract. So remember, it's divide, multiply, subtract, and then remember the next step usually is bring down, but there's nothing to bring down. So that's the remainder, because x squared won't go into minus x. So we can now write that function as x, because the whole number x, minus, and we've got to say, well, that's the remainder. It's still remaining to be divided. So therefore, x over x squared plus 1. And that's exactly what we did in partial fractions. The limit of f of x is equal to the limit of f of x as x tends to plus or minus infinity. So there we are. It's limit of that expansion, which means I can separate the limits to there. And now the limit of x as x tends to infinity as a graph stays as x. And this one goes to 0. And you can't have any vertical asymptotes because that denominator cannot be 0. So it's equal to x minus 0. So therefore the oblique asymptote is y equals x. Let's do another one so you get the pattern. F of x equals 2x squared plus 7x minus 4 over x plus 1. Can I suggest what you do first is pause and try doing the long division to remind yourself. So pause the video and just do that little long division first yourself to remind yourself so that you're clear on how to do it. Okay, so here's the long division. What do we say is x into x, 2x squared gives you 2x. And then we multiply. 2x times x plus 1 gives you 2x squared plus 2x. Then we subtract and we bring down. So divide, multiply, subtract, bring down. And now we're ready to start the process again. We divide x into 5x, give you 5. Multiply 5 times x plus 1 gives you 5x plus 1. Subtract, and that's as far as we can go because there's nothing to bring down. So now we have separately, like a whole number I guess you could say, is 2x plus 5, and the remainder minus 9, which still has to be divided by x plus 1. So we write it that way. 2x plus 5 minus 9 still to be divided by x plus 1. Now we have a vertical asymptote. Have a look there. You can't have x equal to negative 1, so x equals negative 1 is an asymptote. And then that separate one is an asymptote on its own, an oblique asymptote. So we say the limit of f of x as x tends to plus or minus infinity is 2x plus 5, because this is going to go towards 0. So there's the oblique asymptote. What it says is as x goes towards plus or minus infinity, the function is going to get closer and closer to exactly 2x plus 5. So the oblique asymptote is 2x plus 5. Let's not do that yet. Let's go back to there. All right. So now what I want you to do is this is the end of this video. So you need to do the exercises as detailed in your lesson notes. It's the curve sketching 3 exercises. Yes, curve sketching 3 exercises, numbers 1 to 3, where all you're doing is you're working out the oblique asymptotes. All asymptotes, in fact. And once you've done that, then we can go on to the next video.